Hello everyone. Today's experiment is going to be about Bourdon tube pressure gauge, and I will be explaining about abstract, objective, and introduction. So for the abstract, the objective of this experiment is to calibrate the Bourdon tube pressure gauge using dead weights. In Bourdon gauge pressure calibration, we are required to compare experimental results with the actual ones. We are also required to find the error in order to calibrate the pressure gauge. Next, for the objective, the aim of this experiment is to calibrate the Bourdon tube pressure gauge using dead weights. For the introduction, as many techniques of measuring the pressure have developed, Bourdon pressure gauge has been one of the best yet the easiest equipment to measure the pressure with. However, today's experiment we are going to measure the pressure applied to the opening tube of the Bourdon pressure gauge. The Bourdon pressure gauge works as the following. It consists of a curved tube of elliptical cross-section which is close to one end. When pressure is applied to one of the tube will straighten outward and will push the pointer to a specific reading. Thank you. I will pass the next presentation to my teammates.
Assalamualaikum and hello everyone. So my name is Sharul Reza. So today I will be presenting our group's apparatus and also methodology for experiment 6. So for the apparatus for this experiment, the first one is Bourdon tube pressure gauge. The second one is dead weight tester, which each of the tester weight 0.5 kg. And the third apparatus is 1 kg piston. So as for the methodology, the first step is the apparatus was set as figure 1. Figure 1 is this figure. Second step, the test gauge reading was ensured to be 0. Then 1 kg piston was put into the Bourdon tube pressure gauge. The third step, air bubble inside the tube is removed by rotating the piston softly. The fourth step, the initial reading of pressure gauge in kilopascal is taken after the system is stabilized. The step number 5, the initial weight of 0.5 kg was put on the piston. After the system is stabilized, the second reading of pressure gauge in kilopascal is taken. Step number 6, the weight on piston was increased by 0.5 kg mass increment. Every time 0.5 kg added to the piston, the reading of pressure gauge in kilopascal is taken. Step number 7, step 5 until 6 is repeated until the maximum weight of 5 kg is applied to the gauge. After that, the weight is unloaded from the piston by decrement of 0.5 kg. Every time 0.5 kg weight unloaded from the piston, the reading of pressure gauge is taken. Step number 8, step 2 until 7 is repeated for 3 times to get the average reading. The last step is all the data is recorded in table 1. This is the table 1 after all mass is added to the piston, then we calculate the average value every time 0.5 kg is added to the piston.
Hi, Assalamualaikum. My name is Aida and I will present theory, conclusion, and also references for this experiment. So the first apparatus is the Bourdon tube pressure gauge. So it consists of a bent, coiled, or twisted hollow metal tube whose end is closed and connected to a dial indicator needle. So when the tube is open to the atmosphere, the tube is undeflected and the needle on the dial at this state is calibrated to read 0 gauge pressure. But when the fluid inside the tube is pressurized, the tube stretches and moves the needle in proportion to the applied pressure, so it deflects when there is pressure. So next is the dead weight tester. So it constructs with an internal chamber filled with a fluid, like oil, along with a tight fitting piston, cylinder and plunger. So a dead weight tester measures pressure directly through application of a weight that provides a force per unit. So when weights are applied to the top of the piston, a force is exerted on the oil in the chamber. The total force F acting on the oil at the piston-oil interface is the sum of the weight of the piston plus the applied weights. Since the piston cross-sectional area AE is known, so the pressure is calculated as P equals to force over area E. So calibration aims to minimize any measurement uncertainty by ensuring that the test equipment is accurate, also because the tube tends to become weaker with extended use. So for this experiment, we need to use few equations or formula to calculate. So the use of the piston and weights with the cylinder generates a measurable reference pressure, which first is the formula pressure equals to force over area, and next is force equals to total mass, including the mass of the piston, times with the gravity acceleration.
So good evening. And for this experiment, I will present the result and discussion for my group for this experiment. So as you can see the table here, this is the result that is obtained that was done during this experiment. So as you can see, there are the loading of gas pressure, the unloading of gas pressure, and each experiment is done 3 times to get a more accurate average value. And then we also calculate the percentage error for the loading and the unloading of the gas pressure. And then next up is the uh, discussion. So the first question of discussion is find the percentage of relative error for the theoretical and measure experimental pressure gauge. So the hint that was given is that a piston of known area is loaded by unknown weights. Therefore, the equation, the theoretical equation is pressure P is equal to F over A, which is force over area. So the measured experiment pressure can be obtained from reading of the Bourdon tube pressure gauge. And the information that we get is that the mass of piston is 1 kilogram, and then the cross-sectional area of the piston is 3.1731 times 10 power of 4 negative 4 meters squared. The true pressure exerted by piston is using the equation of mass of the piston multiplied with the gravity 9.81 times 10 negative 3 and divided by cross-sectional area of the piston. And from this calculation and unit conversion, we can get that the true pressure exerted by the piston is 30.9 kilonewton per meter squared. And then the total pressure exerted by the total mass is the basically the total mass of the weight and the piston multiplied with the gravity, and then divided by the cross-sectional area of the piston, which we can get the value of 46.4 kilonewton per meter squared. And then for the average reading of the calibrated, average reading of calibrated pressure, we add all of them, all of the 3 experiments, and then we divide by 3 to get a more average value. Percentage error for loading is the measure value minus with the actual value over the actual value times 100%. Same for the unloading, 40 minus 46.4 over 46.4 multiplied with 100%, which we get 13.0%. So the second question of the discussion is the source of error and method to minimize the error. So the source of error can be the external forces may be present that present may able be affecting the reading. So in order to avoid this error, we need to repeat the experiment multiple times to get a more average value. The second source of error is that air bubble may be present inside the tube. So if there's air bubble, we need to remove it because it can disrupt the reading of the experiment. Next is the eye level of the observer may not be perpendicular to the reading scale. Make sure that our eye level is perpendicular when taking the reading to avoid any unnecessary errors. So for the third question is that the repeatability and accuracy of this equipment. So what it means by repeatability is that repeatability of this equipment is the values of repeated measurements that fall under the same conditions such as mass. And the accuracy is the accuracy of this equipment means whether the average value that we recorded is almost the same or similar with the true value that is given. So that is all for my part. Thank you very much.
So the conclusion for this experiment aims to calibrate a Bourdon tube pressure gauge using dead weights. So the gauge pressure is measured every time the weight increased. By using the dead weights, the gauge pressure is recalibrated as the accuracy of the gauge is reduced over time. The percentage error for loading is 34.7%, while for unloading is 13.0%. The uncertainties in this experiment could be from random and systemic errors in experimenting. So lastly is the references. So we refer an article and also a book. So the article is the estimation of error in Bourdon type pressure gauge using dead weight tester, and also the book we referred is Fluid Mechanics by Yunus Chungal. So that's all from me.